All right, today's lesson is on describing two categorical variables. So today we're going to be discussing stop and frisk, a New York City program in which police stop individuals on the street if they have reasonable suspicion that a crime is being, or is about to be committed. If police search the individual and find evidence of criminal items or activity, they can make an arrest or issue a summons. Rather than the typical reactionary model of policing in which officers respond to calls of crimes already being committed, one of the goal of programs like stop and frisk is to be proactive and therefore potentially prevent more crime. However, stop and frisk has at times been controversial with some New York City residents, alleging that police discriminate in terms of who they choose to stop and how they treat the people that have been stopped. A unique aspect of the program is that the police record highly detailed data for each stop. This data allows both supporters and opponents of the program to review it closely. So with that data, we'll explore this key question for today. Is stop and frisk discriminatory? So we're going to cover 5 topics today, starting with joint and marginal relative frequencies. For investigation, we'll use the data from all the stops from the year 2020 among individuals from these racial groups. Note that all of this data was recorded by New York City police officers and is publicly available at nyc.gov. Note that other groups, such as those from Middle Eastern and Native American descent, did not have a high enough sample size for this analysis. So if you really want to see all that data, you can get on nyc.gov. But for today, we're just going to keep it simple with just these 4 groups. This data is organized into a 2-way table, which is a table of counts describing 2 categorical variables. Note that these tables are also sometimes called contingency tables. The 2 categorical variables displayed here are the race of the stopped individual and whether the police found a criminal offense during the stop. When analyzing a 2-way table, a good first step is to find all of the totals, both for the rows and for the columns. And this is what that looks like. Let's break it down. The totals of these vertical or up and down categories are called the column totals. This column total here displays the total number of Asian individuals who were stopped. The totals of these horizontal or left and right categories are called the row totals. This row total here displays the total number of stops that discovered crime. The table total, or the total number of stops described in the whole table, can be found in this bottom corner. You can find it by adding the row totals, or you can find it by adding the column totals. Either way, you should get a match. One item we can find from a 2-way table is a joint relative frequency. That's an individual cell frequency divided by the table total. For example, let's look at this question. What proportion of stops were of Hispanic individuals and found no criminal activity? In the table, we see that these 1,226 stops meet that criteria, describing the joint traits of Hispanic and no criminal activity. That's why it's called the joint frequency. It's these 2 traits joined together. To get the proportion, we divide the joint frequency by the table total of 9,321 stops, which gets us a proportion of about 0.132, or 13.2%, meaning 13.2% of stops included a Hispanic individual and found no criminal activity. One note, another way that 2-way tables are sometimes displayed is through only joint relative frequencies. In other words, you take every cell value, divide it by the table total, and show the proportion of individuals or observations in each cell. When it's done this way, the table total will always be 1 or 100%. So one initial question we might ask about this data is, who do police tend to stop? To answer this, let's find the racial distribution of stops. In other words, we're going to focus on these column totals, which describe the number of stops among each racial group, regardless of whether or not crime was found. Specifically with each column total, we're going to find what's called the marginal relative frequency, or the proportion describing a category from one variable in the table. Similarly to how a piece of paper has a top margin and a side margin, each 2-way table has one variable in the top margin and one variable on the side margin. The marginal relative frequency focuses on just one of these margins or one of these variables, and it's calculated by dividing a column or row total by the table total. Let's break down how it works. To see the racial distribution of who was stopped, regardless of whether or not criminal activity was found, we can find the marginal relative frequencies for race. First, we can see that there are a total of 219 Asian individuals stopped by police. So that's 219 individuals out of a grand total of 9,321 stops, which is 0.023 or 2.3% of all stops were of Asian individuals. There are 6,196 Black individuals stopped by police. Out of 9,321 total stops, that comes out to 66.5%. So we can see that the marginal relative frequency is much higher here, as 66.5% of all stops were of Black individuals. Continuing through the process, we find the marginal relative frequencies for Hispanic and white individuals are 22% and 9.2% respectively. So we can see that police tend to stop Black individuals the majority of the time. In addition, taken together, we can see that police tend to stop Black and Hispanic individuals a large majority of the time. These two groups alone make up 88.5% of the stops. But this analysis raises an important question. How does this distribution compare to general racial makeup of New York City? One way to answer that is by using a side-by-side bar chart. We begin with the marginal relative frequencies from the police stop data. We compare it to the racial distribution among the whole population of New York City shown here. As mentioned, the percentages are only calculated out of these four groups. To visually compare these numbers, we can make a side-by-side bar chart like this. So with both data sets visualized together, what do we notice? It's clear that Black individuals are stopped at a disproportionately high rate compared to what we would expect if we'd sampled randomly from the general population. All of the other groups, by contrast, are stopped at disproportionately low rates. For critics, this data is concerning. However, supporters of the stop and frisk program say that there is a reason for these trends. For example, here's a statement from Michael Bloomberg, the longtime former mayor of New York City, who expanded the stop and frisk program during his tenure. In a speech at the Aston Institute after leaving office, he said, quote, "People say, oh my God, you're arresting kids for marijuana who are all minorities. Yes, that's true. Why? Because we put all the cops in the minority neighborhoods. Yes, that's true. Why do we do it? Because that's where all the crime is." Today, advocates for stop and frisk make similar claims. Are these claims supported by data? Let's investigate. To do that, we'll explore conditional relative frequencies. To investigate claims about crime rates, we're going to calculate the crime rates found among each racial group in our data set. When we see this sort of language, such as for each, within each, or among each group, this means we need to find what's called a conditional relative frequency. That is, the proportion of a subgroup that meets a certain condition. It's calculated by dividing an individual cell by its row or column total. Let's break down how this works. First, let's find the crime rate discovered during stops of Asian individuals in our data set. Since we're looking at the crime just among Asian individuals, or conditional on Asian individuals, I can ignore the rest of the table except for this column, which describes all the Asian individuals in our data set. We find that 77 out of 219 Asian individuals stopped were reported for a criminal offense. That's 35.2%. And 142 of those 219 Asian individuals had no crime found. Dividing gives us 64.8%. Moving on to the next column with the data for Black individuals, we can see the yes out of the total was 39.2%. That's the total number of Blacks divided by the total. And then no crime comes out to 60.8%. We can do it with the remaining groups. We get 40.2% and 41.1% for Hispanic and white, respectively. And no crime was 59.8 and 58.9, respectively. Now that we've done these calculations, it's helpful to visualize these values for our analysis. So how can we do this? Two good graphs we can use are segmented bar charts and mosaic chart plots. For a segmented bar chart, we can set up our axes like this. Note the key on the right-hand side. Remember that for Asian individuals stopped, crime was 35.2% and no crime was 64.8%. We can graph the crime rate like this, and then stack the bar for the remaining 64.8%, which found no crime. Note that combines to 100%, which should describe all of the stops made among Asian individuals. We can continue to build the graph the same way for the other three groups, and we get the following. This is known as a segmented bar chart. Another chart type we could use is a mosaic plot, which looks like this. As you can see, a mosaic plot is similar to a segmented bar chart, except that the bar widths are proportional to the sample size. Because there are fewer stops involving Asian or white individuals, those bars are narrower. But because so many Black individuals are stopped, that bar becomes much wider. Note on the AP exam, you generally won't be asked to draw a mosaic plot yourself, only to interpret them like we're doing here. So going back to our segmented bar chart, we see that crime rates were fairly similar among each racial group. The bar heights for both categories look pretty similar across each race. That said, we can still ask, is there any evidence of an association between crime rates and race? So let's talk about how to describe associations. So the question is whether there appears to be an association between race and crime rate. That word association means, do the crime rates differ among racial groups? When you're asked about an association, you'll need to do three things. Make a claim stating whether or not there's an association, support that claim by comparing the percentages and include context by mentioning the variables involved. One key note here, when you're making the comparison, you'll need to use comparative words like higher, lower, or similar. So remember that we saw that overall crime rates were fairly similar among each racial group. Yet there were some noticeable differences, particularly among Asian and white individuals. In describing this association, we can say that there appears to be a slight association between race and the rates of criminal activity found during stops. Here I've made a claim that there's a slight association, and I included context by mentioning the two variables, race and rates of criminal activity. Adding on, we state specific data. For example, police discovered criminal activity among 41.4% of stopped white individuals, which is higher than the stopped Asian individuals. Here's where I get to comparison, where I'm comparing two percentages using the comparative word of higher. Now that we've done this analysis, let's go back to Bloomberg's claim, particularly the last part, quote, because we put all the cops in the minority neighborhoods. Yes, that's true. Why'd we do it? Because that's where all the crime is. And again, supporters of stop and frisk today make similar claims. Are these claims supported by this data? When we look at the conditional distributions, we find that reported crime rate among white individuals was slightly higher than among other groups, and that overall crime rates were fairly similar among each racial group. Therefore, Bloomberg's claim about crime rates is not supported by this data. And it's worth noting, this data can't definitively prove or disprove his claims. For example, the rates of crimes discovered by police stops may differ from the rates of undiscovered crime. Still, the mayor made these claims during a speech on stop and frisk. And this data from the program, without making outside assumptions, falls short of supporting those claims. For the record, though, he has since retracted his statement. He no longer supports stop and frisk. Now to our discussion. Imagine a supporter of the stop and frisk program says, hold on for a second. There's another way to analyze this data. Going back to our data, let's look at just the stops that found crime. When considering just this row of the two-way table, we see that 77 of the 3,684 criminal offenses, or 2.1%, were from stops of Asian individuals. 66% of the criminal offenses were from stops of Black individuals, and Hispanic and white accounted for 22.4% and 9.6%, respectively. So if we consider the racial breakdown of just the stops that found crime, we find that Black and Hispanic individuals make up 88.4% of stops that discovered crime. So this raises our discussion question for today. Does this new analysis provide compelling evidence for Bloomberg's claim? Why or why not? And here's a hint to help you think about this question. Take a closer look at the mosaic plot we showed earlier. So when you're ready, jot down your initial thoughts. We'll discuss this further in class. That's it for today. See you next time.